Right, so welcome to this particular video where we'll be looking at questions or problems involving electric fields and electric forces. So question one reads, a small ball of mass 0.015 kilograms is suspended floating in an electric field of magnitude 5,000 newtons per coulomb. Question A, if the electric field is pointing straight up into the air, what is the charge on the ball? What is the charge on the ball? And B, if electric field points straight down, I suppose this question is also supposed to read what is the charge of um or what is the charge on the ball if the electric field is pointing straight down. So they're trying to give us two scenarios where there's the electric field pointing straight up and the electric field pointing straight down. So we should calculate the charge on the ball if it is being exposed to this particular electric field. Okay, so this is a very simple question. Why am I saying it's very simple? It's because by now we all know to say uh, with electric fields, when an object is exposed to an electric field, what happens is that there is a resultant force that is going to, or that it is going to have on that particular object. For example, in this case, they've given us a ball. That means we're going to use a ball as a reference, or this small ball as a reference. If it is exposed to an electric field, it is going to have a resultant force that we call electrostatic force or electric force. So in this case, they've said the ball is suspended in an electric field. If it is suspended, ladies and gentlemen, what should come first into your mind is that it is not moving. There is no net movement of this particular small ball. It is suspended in one place. So what does that mean? That means the forces that are acting on this particular ball are what? Are balanced. All the forces that are acting on this particular ball have been balanced. That's the reason we are having this ball suspended in an electric field. So let's look at the forces that are acting on this particular ball. They've given us to say this ball has mass. They didn't say it has negligible mass. They've specified to say it has mass of 0.015. And if it has mass, that means there is a force of gravity that is acting on this particular ball, which means it is having a force pointing straight down, which we're going to call mg, as usual. And since we've said it is at equilibrium, there's no net movement. That means the forces on this particular object or this small ball are balanced. That means we are going to have an electric field acting straight up. They've specified in part A to say it is acting straight up. And if it is acting straight up, it is going to have a resultant force in the upward direction that we're going to call an electrostatic force or an electric force. So up here, we're going to have a force that we're going to call electrostatic force or Fe. If you want, you can write capital E. These are just basics. I'm sure we all know about this by now. Okay, so this is what we have. Electrostatic force, Fe, is a product of the electric field itself or magnitude of electric field and the magnitude of charge on that particular object. So Fe is equal to, if I'm writing the formula for electrostatic field or electric field, I'm going to say my electrostatic field Fe is equal to Q, which is magnitude of a charge, multiplied by E, which is the electric field. This is what I'm going to have, ladies and gentlemen, or this is the formula for electric field. And since they've said these two forces, or this object is at equilibrium, that means these two forces are balanced, which means Fe is equal to mg. And that's exactly what I'm going to write. So I'm going to say Fe is equal to mg like that. And I'm going to replace Fe with its Q multiplied by E, of which Q is the magnitude of charge multiplied by the electric field itself, or magnitude of electric field, will be equal to mg. This is what we're going to have, or this is our formula. So now what is our job? Our job, we've been told to calculate the charge. And that's simple. Just like that, the charge is what we are looking for. So we're going to make E the subject or Q the subject to the formula, of which Q is just basically standing for the magnitude of charge. Q will be equal to mg divided by electric field. So our Q will be equal to mg, mass is 0.015 multiplied by 9.81 over the electric field, which is 5,000, over the electric field, which is 5,000. So our Q, to show that we're looking for magnitude of Q, we're going to put those absolute signs there. I plug this into my calculator. I'm getting 0.147 divided by 5,000, meaning the magnitude of our electric field is equal to 2.94 times 10 to the power minus 5 coulombs. So the charge, the magnitude of charge, sorry, is equal to 2.94 times 10 to the power minus 5 coulombs. So this is the magnitude of the charge. Now, the question is saying if the electric field is pointing upwards. If the electric field is pointing upwards. Let me check the question again. Okay, so A, if electric field is pointing straight up in the air. Okay, so this is the magnitude of our electric field. So if they say, or they've specified in the question to say up and down, this is the overall magnitude. Now we're just supposed to apply the signs of our electric field. Where should our electric charge, or where should our charge point? So we're going to notice to say in the first case where the electric field is pointing up, for the ball to float, the electric force or the electrostatic force must act upward. This force, the way I've drawn this diagram, this force must act upwards to balance the mass of or to balance the weight of this particular ball, which is acting downwards. So what does that mean? That means the electric field must be in the direction of the electric force. I'm sure I understand that. The electric field is pointing up. That means the electrostatic force um, should also be upward. And what does that mean? That means Q will be positive. So in part A, the answer is basically going to be equal to positive 2.94 times 10 to the power minus 5 coulombs. Whilst in B, what is the case in B? So in B, they've said the electric field is pointing downward. The electric field is pointing downward. So now that this electric field is pointing downward, for the ball to float, electrostatic force must still point upward. Electrostatic force needs to point upward so that it balances the weight of this particular object. So if the electrostatic field, where is it? Where is the formula? Okay, this formula that I've shown here. Let me just explain using the formula so that people can understand. So we've said the Fe should be positive. It should point upward. So this we've said is equal to Q multiplied by E. So if E is pointing up, and Fe, the electrostatic force needs to be pointing up to, it needs to be positive, which means these guys both needs to be positive, right? That's why I've said in part A, Q should be positive. That's why I've said Q is equal to positive 2.94 times 10 to the power minus 5 coulombs. Now, what about in part B, where E is negative, or P in E is pointing downwards? Whilst we still need Fe to be positive, or we still need Fe to be positive and point upward. What are we going to have? So using your common sense, I'm sure we've already solved that one. So in this case, that means Q should be negative so that we get a positive Fe, which is pointing downwards. If E is pointing down, that means Q should be negative so that we come up with a positive electric force or positive electrostatic force. So in B, we're basically going to say the answer will be negative 2.94 times 10 to the power minus 5 coulombs. Just like that, we are done with question 1. We can move on to the next question, which is question 2. Question 2 is saying an electric field of 100,000 newtons per coulomb causes a 5.0 gram point charge to hang at a 20-degree angle. An electric field of 1,000 or 100,000 newtons per coulomb causes the 5.0 gram point charge to hang at a 20-degree angle. What is the charge on the ball? What is the charge on the ball? Yeah, so here, this question will be approached in this manner. So we've been given to say we have an electric field of 100,000 is a vector, newtons per coulomb. It's in the x-axis. So let me put the dash there. Okay, yes. Then it is having or the point charge has a mass of 5.0 grams. I can convert this into kilograms by dividing it by 1,000. This is going to give me 5.0 times 10 to the power minus 3 kilograms. Okay, like this. Then what else? They've also given us theta, which is 20 degrees like that. Okay, so the first thing we're supposed to do here, let's visualize this question. Let's draw a free body diagram for this particular question. So we have, okay, so I'll say we have a point charge that is suspended. Okay, I'll just say it's there. This is the y-axis. Then there's an angle, theta here, which is 20. Let me draw a much bigger diagram. And let me draw it just here. Okay, so we're going to say we have our y-axis, okay, yes. So this is our point charge there. And there is an electric field which is pointing in this particular direction. So we have a theta here of 20 degrees, and we have tension in this particular string that is holding the point charge. We have tension there, and this tension is going to be resolved into its respective x and the y components. So we're going to have the y component of our tension there and the x component of our tension pointing in that particular direction. So since the electric field E is pointing in this direction, what are we going to have? We're going to have an electrostatic force or an electric force pointing in the direction of the electric field. So what are we going to have? We're going to have Fe pointing in this particular direction, the electrostatic force. Then the tension, the angle here is the same as 20 also. So it is adjacent to the y component. So we're going to have T. It is going to carry a cosine. T cos 20 degrees here. Then in the x-axis, we're going to have T sine. It is opposite to the given theta, so it is going to be T sine 20 like that. Then this point charge has mass, so the mass will be acted upon by the force of gravity to produce weight here, which will be equal to mg. These, ladies and gentlemen, are the forces that are acting on this particular point charge. We have tension in the x and y components. We have the electrostatic field, or rather, we have the electrostatic force or the electric force due to the electrostatic field that we've been given here. And we have the weight of the point charge due to the force of gravity and its mass. So if these are the forces that are acting on this particular object, our goal is to calculate the charge on the ball. Our goal is to calculate the charge on the ball. That is what they've asked for in the question. So what are we going to do? We're going to consider the forces in the x and y axes respectively, since we know to say they are all at equilibrium. The force is causing, the electrostatic field is causing this point charge to be suspended at 20 degrees at an angle of 20 degrees, just like that, just the free body diagram. So I'm going to say in the x-axis, in the x, I'm going to have T sine theta, or this will be negative since the pointing in the x direction, or rather in the negative x direction. I can say Fe, electrostatic force, minus T sine 20 degrees, this being equal to 0. That means Fe is equal to T sine 20 degrees, like that. What is the formula for Fe? We've talked about this in question 1 to say electrostatic force is a product of the magnitude of charge multiplied by the magnitude of electrostatic force, or rather the electric field. So we're having that. We're just going to plug it in where we have our electrostatic force. So I have my Q multiplied by E being equal to T sine 20 degrees, like that. This is the formula that I'm having. So let's now consider the forces that are in the y-axis. In the y, we have T cos 30 or T cos 20 and mg. So the same thing is going to happen. I'm going to have T cos 30, cos 20, T cos 20 degrees being equal to mass multiplied by gravity, just like that. Then if this is the formula that I'm having now two formulas. I have this one in the x-axis and this one in the y-axis. So let's write the formulas in such a manner that they should look the same. I'm going to have T sine 20 degrees being equal to QE as my equation 1. Then I have T cos 20 degrees being equal to mg, and this as my equation 2, like that. Okay, so if this is what I have, what am I going to do? We're going to combine the two expressions. We're going to combine these two expressions. How are we going to do that? We're going to divide equation 2 into equation 1. We've done this a lot, even under equilibrium forces, vectors. We've been doing such things, so it shouldn't be new today. So I'm going to have my T sine 20 degrees over T cos 20 degrees being equal to QE over mg. This is what we're going to have. T and T are going to cancel out. Therefore, we're going to remain with uh, tan 20 degrees being equal to charge multiplied by electric field over mg. This is what we're remaining with. So we can now substitute in the values that we know so that we can get our Q, just making Q the subject to the formula. And it is as simple as that. So let's make our Q the subject to the formula. How are we going to do that? We're going to cross multiply like that. We're going to have mg tan 20 degrees. This will be equal to Q, and that over E. This will be the formula that is going to give us the magnitude of the charge on this particular ball. So we'll get our Q magnitude will be equal to the mass, which is 5 times 10 to the power minus 3 grams or 3 kilograms, multiplied by gravity, which is 9.8 and 20 degrees divided by 100,000. Divided by 100,000. And our magnitude of Q will be equal to, let me just plug this in. We have 5 exponential minus 3 multiplied by 9.8 tan 20 divided by 100,000. Okay, so I'm getting 1.78 times 10 to the power minus 7 coulombs. 1.78 times 10 to the power minus 7 coulombs. So ladies and gentlemen, the charge on this particular ball, is equal to 1.78 times 10 to the power minus 7 coulombs. And that is all on question 2. So thank you very much for watching this particular video. Make sure to subscribe to the channel, give it a like, share, and register with our tuition center using the procedure that I've included below or in the description of this video, and also the description of my channel, to help you prepare with your exams with all the necessary materials that you need, starting from tutorial sheets, past papers, and all sorts of stuff in all the 4 pre-med courses, which is math, physics, biology, and chemistry. So until next time, ladies and gentlemen, stay blessed.